Welcome. Tonight you'll be learning some graphical analytical tools that can help you organize data in a way that can impress your boss. We'll walk you step by step through creating bar graphs, pie charts, and even histograms. So let's get started. Let's begin with bar graphs. So what exactly is a bar graph? Well, a bar graph is a visual representation of categorical data with bars of heights or lengths proportional to the values that they represent. Bar graphs are a simple yet effective way to display data. So you might be asking yourself, when would I even use a bar graph? Well, a bar graph can be used to compare things between different groups or to even track changes over a period of time. So now let's go to Excel and let's walk you through it step by step. We'll be using some data from our provider referral correspondence project. In this project, we're looking at data from Dr. Singer's failed faxes. Each failed fax report is sorted by different categories. Let's utilize a bar graph to visualize the difference in failed fax categories. First, let's highlight the data we want our graph to represent. At the top of Excel, select Insert and choose Bar or Column Chart, depending on if you want vertical or horizontal bars. You will also get to choose from clustered or stacked charts, or 2D or even 3D. For the purpose of our data, we will choose Recommended Chart to see which type of chart is best for the data we're analyzing. Because we are comparing values across a few categories, Excel is recommending we use a clustered bar chart. By selecting OK, our graph populated along with the chart of the amount of failed faxes per category. Now we can clearly visualize the categories with the most and the least amount of failed faxes. It's that simple. Now that you've mastered bar graphs, let's move on to pie charts. So what is a pie chart? A pie chart is a circular statistical graphic divided into slices to illustrate numerical portions. So when would you use a pie chart? Pie charts are used when you need to show percentages of a whole at one specific point in time. So you might be asking, what are the benefits of a pie chart? Well, pie charts can be used to summarize a large data set in a visual representation in a simple yet effective manner. Now that you've mastered pie charts, let's take a look at another example. Again, we'll be using the data from Dr. Singer's failed fax reports. This time, let's try to analyze the amount of numbers that were actually fax numbers compared to the amount of numbers that were not real fax numbers. We were able to break the data into a table. So first, let's select all of the data, hit Insert on the top, and select Pie Chart. Here, you'll have the option to select different types of 2D and 3D charts. For the purpose of our data, let's select 3D charts. Once your data appears, you can edit the options to illustrate your data in the best way possible. And just like that, you've mastered pie charts. Let's move on to histograms.
The last graphical analytical tool that you'll be learning tonight is histograms. Well, what is a histogram? It is a visual interpretation of numerical data where the number of data points fall within a specific range of values represented each by bars or bins. The height of each bin shows the number of times that the values occur within the intervals, while the width shows the interval that it is covered. While a bar graph uses categorical data, a histogram uses quantitative data, and there are no gaps between the bars. You can think of a histogram as a snapshot in time of the variation in your process. Well, why are histograms important? Histograms provide a quick visual representation of data distribution that can help you determine where the center of the data lies, which is the median of the data, how the data is shaped, which provides information where the data is concentrated and its frequency, and how the data is spread across the graph, which indicates variation and if a process is capable or not. It can also display the range of a large amount of data graphically that would be difficult to understand in a spreadsheet form. Lastly, it can show any outliers or gaps in the data. When should you utilize a histogram? You should use a histogram to analyze data that is continuous or variable, to see the shape of data's distribution, which can tell you if the data is symmetric, if it's skewed to the right, if it's skewed to the left, etc., to analyze how the output of process relates to the customer's expectations and if the process is capable of meeting the customer requirements, to see whether a process change has occurred from one period to another, and finally, when you need to communicate the distribution of data quickly and easily to others. Now it's time to learn how to make a histogram using Excel. To understand the application of histograms and how you can use them to analyze the capability of a process, let's use the sample data provided in Excel to create a histogram on QI macros. You first want to highlight all of the sample data on the spreadsheet. Once the data is selected, you then click on the QI macros tab in Excel. You then select the Histograms and Capability tab. As you can see, you have a few options depending on the histogram that you want to generate. For this example, I will select the second option, Histogram CP/CPK normal. You will be asked to select upper and lower specification limits. Specification limits allow you to assess how capable your process is of meeting the customer requirements. Let's say the upper spec is 346 and the lower spec is 200. How many bars do we want? Usually the default value that is provided in QI macros is good to use. Voila! A histogram. Wasn't that easy? You now have a visual representation of the sample data that I used. Here is the lower spec limit and the upper spec limit. You can see some values being outside the upper spec and the lower spec limits. That means that the process is out of control. Not only does QI macros histogram allow us to gather information like the mean, median, and mode of the data, but like I mentioned, it allows one to see how capable the process is. Let's look at CP and CPK values, which are short-term capability measures, where CP tells us about the variation and CPK tells us if the data is centered to the mean. Normally, CP values of 1.33 or above are considered acceptable and a value of 2 is excellent. What does a CP of 0.76 tell us about the process? This means that the process is wider than specification, there is high variation in the process, and some values are outside the upper and lower spec limits. Well, what does a CPK of 0.67 tell us? A CPK that is less than 1 tells us that the overall average is not centrally located. Overall, this process is poor and is not capable of meeting its requirements. This information should prompt you to determine why your process is not capable to be able to then eliminate the causes of variation from the process to make it stable. You should now have a better understanding of pie charts, bar graphs, and histograms, which will allow you to make more sense of the next data set that you receive. Thanks for watching! Like and subscribe for more educational videos.